We begin our study of statistics in section 1.1, where we are going to lay down for ourselves a foundation of vocabulary terms so that we have this kind of common ground of an ability to communicate what we're talking about when it comes to statistics and probability. So the very first of these terms that we need to make sure we define and understand is variable. It says this: a variable is a characteristic or an attribute that can assume different values. So something that can assume different values, for example, color, or weight, or height, okay? Or dollars for that matter. How much does something cost? Each of these characteristics is a characteristic or an attribute that can assume a different value. Color of a car. There's a whole assortment of different values of that a color of a car can assume: red, green, blue, white, black. Same with weight. The weight of dogs, the height of humans, the cost of fuel can assume different values. So a variable is just simply anything that we are interested in that has the ability to assume different values. Now, we're interested in actually collecting those values, and when we do collect those values, we call each of those pieces or each of those values data. So data are the actual values, the measurements or the observations that the variables can assume. So for instance, if we're looking at color, I look at my first car and I see that it's a red car. The next car is black. The next car that I look at is white. The next car that I look at is brown, and so on and so forth. Each one of these are data points. They're the actual values. Notice by values, we don't always mean numbers. It's either a measurement or an observation. I observe that the car is red, or I observe that the car is black. Now, the next key concept that we've got to understand is this concept of what we mean by a random variable. It says this: variables whose values are determined by chance are called random variables. Now we have to understand this correctly, because what we're saying is not necessarily that the measurement is random, but that what we are selecting is random. The key difference there is in the descriptor of what is the random piece that we're talking about. Okay, here's what I mean by that. Right, if I go out and randomly select a board from my wood shop and I measure it, right, that board has a specific length. Let's say that it's 4 feet. Right? Well, is the length of that board random, or was the selection of that board random? That's the key that we're wanting to make sure that we understand, right? More often than not, when we're talking about random variables, right, what we're talking about is that the data value, the measurement or the observation that we're getting is random, not because the board decided to randomly choose its own length, but because the board was randomly selected. For that matter, going back up to the color of our car, right? It's the fact that the car, the vehicle that we're looking at and determining what color it is, that the vehicle was selected randomly. Okay, so when we're talking about random variables, what we're really getting at is this, is as I'm randomly selecting the things that I am measuring or observing, and then determining the actual measurement or observation value, right, it's the selection of those things that we're really keying in on as being the random part. Okay. Next, we have a collection of data values forms a data set. Using this example that we have right up here, where I looked at 4 different vehicles and their color, right? Each one of these colors, right, is an individual piece of data from the variable color, right? all of these colors combined together make up my data set. So my data set is a combination or a collection of all of the actual data values compiled together in one location or in one area for us to use and analyze. Now, this last term here on this first page that we're looking at is a little bit redundant in that we looked up here at data as values. So what's a data value? Right? Each value in the data set is called a data value. A little bit redundant, but there's this other word right here, this other term that's connected to it called datum. Datum is just another way of saying data value. You'll very rarely see that that term used, but we just need to make sure that we understand when we see datum, we mean data value. It's each value in the data set is called a data value. So every value is its own datum. Okay. Good. So we've got some terms to work off of so that when we use them now, we know what we're talking about. Okay. Two more terms that are going to become really important as we move through this course. This idea of a population and a sample. It says this: a population consists of all subjects, human or otherwise, that are being studied. Okay? And really the best way to understand what a population is to compare and contrast it to a sample. A sample is a group of subjects selected from a population. One of the best ways to understand this is to visualize your population as a big circle. So in other words, everything that I'm interested in studying fits inside of this circle. Here's the problem though. What if everything that I am interested in studying is every single citizen in the United States? That is a massive amount of people. It's over 300 million people. Right? There's no way that I'm going to be able to legitimately study all of those people. So what do? Well, I find a sampling of those people. So I say I'm going to find a smaller group within my population that hopefully is representative of my population. Right? Now, you guys are probably aware that this happens. Think politics, for instance. What do? They collect information from a sample of people about which candidate they support or which measure they support or don't support or what they feel about a certain topic that's within our culture politically. Right? Personally, I've never been asked any of those questions, yet those studies exist. Why? Because instead of asking every single person in the entire population those questions, they're finding a sample from the population to ask those questions of. The same could be true if we're interested in studying all the coral reef around the entire world. Well, good luck with that. That's going to take you decades, if not centuries, to do that. So what are they going to do? They're going to pinpoint a few specific coral reefs, study those, and hope that those are representative of all the coral reefs in the world. Right? So this idea of sample and population is going to become really critical as we move through this course, especially the second half of the course when we get into something called inferential statistics, which we're going to look at here in just a moment. So, but for now, just keep in mind that a sample is a small portion of the total population that we're interested in actually studying. So population and sample. Lastly, in section 1.1, we want to take a look at the difference between two major branches of statistics: descriptive statistics and inferential statistics. Descriptive statistics says this: it consists of the collection, organization, summarization, and presentation of data. In other words, descriptive statistics does things like this. It says, well, the average of something is such and such, or it constructs a chart like a pie chart, which shows how much of fits into different categories of something that you're studying, or a time chart. As time goes on, what happens to the variable that I'm studying. Right? So this is all descriptive. We collected data and we're finding ways to describe what the data is communicating to us, right? So it consists of collecting the data, organizing it, summarizing it, and then presenting it, right? This is in contrast to what we call inferential statistics. The first half of the course, we are going to be dealing pretty consistently with descriptive statistics. But all of that is going to hopefully set us up for the second half of the course, where we're going to be looking at inferential statistics, which consists of generalizing from samples to populations, performing estimations and hypothesis tests, determining relationships among variables, and making predictions. That's the key word, making predictions. The whole goal of inferential statistics takes what we learned about samples and populations and turns it into something that is hopefully useful to us, namely making predictions. In other words, inferential statistics says this: can I gather some information? Can I gather some data using a sample? And can I then, using that data, make some really good predictions about the population as a whole? Okay, so inferential statistics says, can I take a sample, data from a sample, and then make some generalizations about my population, or test hypotheses? Say, I think this is the case. Can I collect data from a sample of my population, and does that data confirm or deny the hypothesis that I'm proposing? Okay. Now, inferential statistics relies heavily on a word you've probably heard many, many times: probability. In other words, the chance of an event occurring. Okay. So one of the sections that we're going to be taking a look at really helps us define and understand this concept of probability, how to calculate it, and how to appropriately use it. But right now, understand probability as what is the chance of a certain event occurring. And lastly, just so that we're aware of this term, this is going to come up quite a bit the second half of this course, is the area of inferential statistics called hypothesis testing is a decision-making process for evaluating claims about a population based on information obtained from samples. A really good example of this, going back to the politics example, is this: how in the world, when only 20% of the votes have been counted, can a news agency claim that a certain candidate has won, or a certain ballot measure has succeeded or not succeeded? It's all in this realm of hypothesizing. Can we take a small amount of data, observe what's happening there, and make a conclusion about the full population? Once I've collected a certain amount of data, is there enough evidence to be confident in making a claim about the full population? That's what hypothesis testing is going to do for us. And there's some really neat ways that we can quantify and discuss how to move forward in using a sample to make predictions and to make decisions about full and claims about full populations.